Hello class, this is a video tutorial on the proofs of extension identities part 1. While these are not required to be able to answer basic questions, they will show how all of the other identities can be proven. This really just means you can use the given identities or the formula without any of the following proofs. So all the identities that we've seen, these here, you can just use them without having to know the actual proofs, but just for the depth of knowledge, here they are. So let's begin with the difference of angles for cosine. So for cosine, this proof here, to prove this, we use the unit circle once again. This is actually the only one that uses the unit circle. All the others can actually stem from this one proof. So let's pick any point P and give it some angle B. So since this is angle B, this has some distance of X and some distance of Y. Therefore, since cos B is X, sine B is Y, the coordinates of P are X, Y, which are cos B, sine B. Likewise, pick another point Q. It follows the same logic. We draw the triangle. It has some distance of X, some distance of Y. Therefore, its coordinates X of X and Y are cos A, sine A, since the angle here is A. The difference of the angles, so the angle in between them, is just angle A minus angle B. We're going to draw a straight line connecting PQ and call that the distance D. So, to prove this identity, let's take a look at the distance formula for 2 points in a Cartesian plane. So we're already familiar with this coordinates. We let x2, y2, so this is x2, y2. x2, y2 becomes cos A, sine A, and x1, y1 are cos B, sine B. Since this is the distance D, it's actually looking for the distance from P to Q, hence why PQ. And to simplify this, we get rid of that square root by squaring both sides. So we're looking for PQ squared, and after substituting all of the points, we get this expression. Expanding each bracket, expanding this, square the first, square the last, double the product. Likewise with this, square the first, square the last, double the product. Collecting like terms, I've written them so that you can just add them vertically. Cos squared A plus sine squared A, that's the Pythagorean identity, which is equal to 1. Cos squared B, sine squared B is also equal to 1. These two are not like terms, so we just write them as they are. So negative 2 cos A cos B, here it is. Minus 2 cos A sine B, here it is. Collecting like terms of the ones, and these remain the same. Now we're going to factor out the negative 2 from this expression, so we're left with this. So we're left with PQ squared equaling this expression. Now we're going to do the same thing using the cosine rule. So we're going to find the distance between these two using the cosine rule, which is c squared equals a squared plus b squared minus 2ab cos c. C squared is PQ squared. A is the distance OP from O to P, and B is the distance from O to Q. Since this is our unit circle, this is a radius of 1, and this is a radius of 1. Hence why we get that. 1 squared, 1 squared. OP, OQ, same thing. And cos C is the angle in between the triangle. So we're looking at this triangle here, and the angle between them is A minus B. Hence why we have that A minus B. Collecting like terms, 1 squared plus 1 squared is 2. Negative 2 times 1 is just negative 2. And cos of A minus B remains the same. So we have PQ squared is equal to this expression as well. Now both of these are both PQ squared. Now, so we can let them equal each other. So letting this equal this. From here we can see we can subtract 2 from both sides, leaving us with this. Dividing both sides by negative 2 cancels those, and we're left with our identity. And there we have it. Now from here, I hope you can see that we can prove this identity and we can prove the identity using the unit circle as shown here. Now, all the other identities can actually stem from this. It'll get rather long, but I'll continue that in another video. But I hope you can see that these identities don't just come out of nowhere. They are from something logical. So I'll see you in the next video where we prove all the other identities using this one. Hope to see you then. Best of luck.